Everybody hear me okay? Solid. So today we're going to take a look at how you can use some of the newest Bing Maps APIs to solve your fleet, trucking and logistics, and mobile workforce in general problems. So our agenda for the day, I'm going to start with a quick overview, just 3 slides, looking at the Bing Maps platform all up, because it's good to understand that foundation as we move into the fleet and logistics specific stuff. Then we'll look at those new APIs. Over the last 12 months, since the last Ignite, we've released truck routing, a very powerful distance matrix API, an Isochrone API, which basically calculates your drive time, your area that you can reach in a drive time, and Snap to Road. Then we'll take a look at a solution that we open sourced this year back in January, and it's a complete fleet tracking solution, and that includes mobile clients for iOS and Android, as well as an Azure backend. And I'll show you how you can deploy that and be live, up and running in just 10 minutes with our one-click deployment portal. So let's start with Bing Maps. I've been working at Microsoft on mapping for about 17 years now, and overall, Microsoft's been working on mapping for 20 years. We got started early on with TerraServer, the first aerial imagery site on the internet, and we've steadily been growing our platform ever since. The team is about 150 engineers that's working on mapping. We now have customers in just about every industry and just about every country that Microsoft sells software in, which is basically everywhere. So when you hear me talk about the Bing Maps platform, it's really 2 things I'm talking about. We have a set of REST APIs that do things like address lookups, geocoding, reverse geocoding. You can render static maps with our REST APIs, access traffic information, transit information, et cetera. And we also have our very visual JavaScript map control. We're up to version 8 on that. We'll look at some of the key features of the map control as well. The map control can be easily embedded into all of your web and mobile applications. Our platform is global. We have mapping and support in over 150 countries. And we've got the world's best documentation, developer support, and customer onboarding, which is really what I spend most of my time at Microsoft doing, is helping our customers and partners get on board with our platform. These are some of my favorite features in the map control. And you can see that we do everything from fancy imagery like bird's eye imagery and street side imagery. We support custom map styles. We just released recently a map style editor, so you can visually make your map look however you want, save off a style sheet and load it up into the map control. It's really easy to load data from industry standard file formats like KML and GeoRSS. You can do heat maps, analytics, everything you'd expect in modern map control. So with that, it's just good to understand we've been doing this for a long time. We've got a very rock solid platform for you to build on top of. Now we're going to look at some of the APIs that we've added over the last 12 months that are ideal for fleet and mobile workforce applications. Truck routing is one of the most popular. This became instantly popular because there's only a few suppliers of truck routing in the industry. Truck routing works, the API works just like our car routing API. With our car routing API, you simply pass in 2 points, and we're going to calculate the best route based on shortest drive time or drive distance. But with truck routing, you can pass in a lot more attributes. And you can see a bunch of them broken out here. Trucks have different requirements of where they can drive. You can see here, this low bridge is a really good example. That's a 9-foot bridge. It happens to be right off of a highway near my house. So if a trucker with a 12-foot bucket truck is getting off that highway exit, and they're using consumer-grade GPS and navigation, it's going to take them under that bridge, and you can see the results of that. And I've lived there for a long time near this bridge, and I'm not kidding. There's been 3 times when I've seen something similar to that. I haven't seen an actual accident, but I've seen trucks pull up to it and get stuck there because it's such a tight area you can't turn around and go back. So some of the attributes that you can pass in for truck routing are obviously the dimensions of your vehicle, the height, the width, number of axles. Can it go over certain classes of bridge? Is it hauling flammable materials, hazardous materials? Do you have a permit for those materials? Can it handle tight turns? All of that can be passed in, and we'll give you back a route optimized for that vehicle. This is just a visual of some of those. This is one of my favorites down here, the Liberty Tunnel, which obviously has height restrictions, but it also doesn't handle flammable materials. So on our website, we have a little demo page where you can try out routes. It looks a lot like this. You can put in your start and end point, and we'll show you both the car and the truck route, and you can play with the parameters for the truck and see how that changes. So I mentioned earlier that we support nearly 200 or almost over 200 countries with our map data. This is the one feature that we only have support for between 60 and 70 countries, and that's because the truck routing data is much harder to acquire. So you can see our coverage is pretty good and is growing steadily, but it's going to take us a while to get all the way up to the same level of 200 countries. But it is a pretty good list. We have a lot of customers in these countries taking advantage of our truck routing API. The next API is our distance matrix, and this is the most complex API in our arsenal. It's one of the most powerful as well, and the simplest way to describe it is think of it as many-to-many routing. If I have many origins and many destinations and I want to optimize my travel between them, for instance, maybe I'm a bakery and I've got 3 bakery locations, and every day I need to deliver to 75 supermarkets. Well, how should I load balance that? Which of the 3 origins should be matched up with the 150 destinations to be most efficient? This API will allow you to pass in all of your origins, all of your destinations. You're very quickly, in milliseconds, going to get back the drive time and drive distance for all of them in a grid. And now you can operate on that grid of data and come up with your optimal solution. And you can see a simple example here. You can eyeball this one. If I have these 3 locations that I need to visit, you can kind of look at that and say, well, I probably don't want to go 1, 3, 2. Either 3, 2, 1 or 1, 2, 3 is going to be my best option. And if you look at the simple numbers that come back here, that proves that out. But now imagine having many more than 3 locations in your matrix. It becomes a much harder problem to solve. Distance matrix can work with real-time traffic and historic traffic information. So you can generate the matrix at any time during the day. In Seattle, as a for instance, our traffic's horrible at 8 a.m. to 9 a.m. It gets okay at 2 p.m. in the afternoon when traffic's died down. So the matrix is going to look a lot different throughout the day. This bullet down here is pointing out that in our distance matrix, we also support a histogram where you can request the distance matrix in 15-minute increments throughout the day. And I'll show you that on a slide. I think it's actually the next slide, so let's go to it. Nope, one more slide, just talking about scenarios, and then we'll talk about the histogram feature. So obviously, these are a few of the use cases for this API. And it's great for everyone from large fleets. We certainly have a number of customers that have started using this API that are managing fleets of thousands of vehicles. But for a local mom and pop shop, it's also applicable. We've got some public transportation companies that are also using it to do things like city planning, where bus stops should be opened, where they're close to people. Pairing this API up with another API that we'll look at next, the Isochrone API for drive time distances, can be a really powerful tool in thinking about public transportation. So now the histogram feature, that, as I mentioned, you can generate the matrix, pass in all of that data, but get back the results in 15-minute increments. Now you can do optimization for your fleet throughout the day, which is a very powerful feature. The Isochrone API, this is one of my favorite to demo because it's actually kind of fun and very visual. What you do with the Isochrone API is you pass in a coordinate, what you're seeing in this image. That coordinate was probably somewhere in downtown Seattle. And then you pass in a drive time, travel time, and you can see here that we've got isochrones generated for 10, 15, 20, and 25 minutes. And you also pass in your mode of transportation. That could be driving your own car, your own vehicle. It could be walking, or it could be public transportation. And what we'll do is calculate from that origin point that you passed in, and given the timestamp where you passed in, we'll consider traffic at that time. So I could say, hey, I'm at this location, and it's 2 p.m., how far can I get? And it'll return the geometry of the shape for me. So what can I do with that shape? lots of things. I can plot it on a map to give the user of an application a visual cue of how far you can get. But I could do things like spatial querying filtering, which we'll look at in a moment. Maybe I want to select all of my warehouses or store locations that are within 30 minutes of a warehouse. That'd be a great use for this. But one that we'll look at later when we get into how we put all of this together for fleet management is Geo-fence creation. Imagine a scenario where you want to create one of these isochrones, let's say a 30-minute isochrone around all of your warehouse locations. Now, whenever you have a truck coming in, whenever it breaks through that Geo-fence, you can send an alert to the receiving, what would you call that? The dock, I guess, so that they can prepare for that certain type of load that's coming in. They may have to rejigger the dock for certain parts that are coming in. And it's one thing to say, well, they're 30 miles away, but 30 miles, as the crow flies, isn't always based on time. So if I can now tell them very precisely, well, that truck is now 30 minutes away, that's a huge boost. This is an example of how you would do filtering with that shape. Imagine you've got, these are just random points that were automatically generated, but over here, you've got my office location, and you can see that that's about a 15, I'm judging, that's probably about a 15-minute isochrone for drive time when I generated that. And I've highlighted in red all of the locations that are within 15 minutes. So you can imagine a scenario, of using this for LinkedIn is a good example, using this for filtering jobs for someone's job query. I could say, well, I live at that location, and I only want to see jobs filtered within a 30-minute commute. I don't want to commute more than 30 minutes each morning. This would be a great tool for doing that. Snap to Road is the fourth API, and it does exactly what the name implies. You pass in a series of coordinates, and we will intelligently snap them onto the road network. Why is that important? Because GPS can be inaccurate, for one, and so you may want to reconstruct the route that one of your drivers was on. This will do that for you. But another very important feature is when we return the route, we return attributes about that road network. And one of the most important is we return the posted speed limit. And a lot of companies will use this for post-drive analytics, where for insurance purposes, they have to know, okay, my driver, I could tell from GPS, he was going 65 miles an hour, but what was the posted speed limit there? Was it 55 or was it 70? Was he in compliance or not? That will, this API will return that information. So that's it for the new APIs that we launched this year. They actually launched a bunch of others, but those are the four that together can really create mobile workforce and fleet management solutions. So now what I want to show you is the Bing Maps Fleet Tracker, which we released as open source in January. And this is a complete fleet tracking, mobile workforce tracking solution. And since we've released it as open source, we've got organizations that are now taking that, both the client code, which runs on iOS and Android, as well as the Azure backend, which gives you a nice web interface, all of your storage stubbed out, and all of the services that are analyzing the GPS data on the way in, all in one nice package. And since, like I said, since it's open source, you can take this, be up and running in 10 minutes, but then customized to no end. As a for instance, what a lot of customers have asked about is, hey, we've got a fleet of 1,000 trucks, and they all have dedicated GPS hardware in them already. Would it work with that? And the answer is sure. You would just have to wire up the code. If you've got GPS in your trucks, you're already sending location information up to the cloud somewhere, whether it's our Azure cloud or maybe you're in a competing cloud or your own corporate application. As long as you can wire up your location information into our Azure backend, you can take advantage of this solution. And it's pretty feature rich. I'm going to show you a demo of it in a moment. These are some of the key features. Out of the box, it works with mobile phones. As I said, we give you the code for iOS and Android, but you can integrate with other sources of GPS information. We make it really easy to register the phones. This is one of my favorite features. Keep in mind, this is your private deployment to your Azure cloud. The data's not hosted by the Bing Maps team at all. So you've got your own private deployment. You want to link your phones up to that private deployment. In the admin tool, we pop up a QR code. Now you can take each phone and shoot that QR code, and it's going to tie that phone into your deployment. We've got great reporting, geofencing. If you're not familiar with that term, geofencing is simply when I've got an area on the map, as I mentioned earlier, and I've got a truck that's going to enter or exit that area, and I want to raise an alert when that happens. So we make it really easy to do that here. I'll show you a great example of that. And it's also a showcase for our truck routing. So within that web dashboard, you can see where your vehicles are in real time. Now you can imagine a scenario where a call for service came in at 22 Main Street, and you want to see, okay, what trucks do I have in the area that are unoccupied right now that I can get over to 22 Main Street? And then when I select that truck, I want to generate the truck's optimized route for the attributes of that vehicle. That's all built in as well. So before I get to showing you Onterra Systems, which is one of our partners that have taken the open source and deployed it, let's take a look at the actual application. So here it is running. I've got a private instance, and you can see I've got 4 trucks here, or 4 drivers. These are some of my work colleagues, along with a fake truck, which just generates some fake data for the purpose of demoing. But what we're looking at here is Justin's trail. This is when he was on vacation. He went down to New Orleans, and if I zoom out a little bit, you can see all of his point history when he was there. And I can also switch and see his routes. So as the data is flowing into the system, we have a service that runs in the background that's analyzing it, and it's looking for places where the driver stopped, and it will add those to a database of locations that you can then navigate and get reports on. And it's also trying to figure out, okay, it looks like he had a stop here, drove for a while, and then had a stop here, so we'll call that a route. And it catalogs those routes, and you can do reporting on that as well. Now, to show you the Geo-fence feature, I'm going to jump over to my colleague, Eric, who works out of our San Francisco office, or his home. I guess he's fortunate enough to just work out of his home office, which is pretty nice. So here's Eric's locations when we were, I think he made this trip while we were demoing at Inspire a couple of months back. And you can see that, you know, this is the area where he generally is driving around. What if I wanted to set a geofence there so that I could know when Eric went into or exited from downtown San Francisco? I'll show you how we create a geofence. We pop over here, and I've drawn this one previously, but if I hit edit on it, you will see the attributes that are available. And you can see that I've given it a name, San Fran. In this case, when he exits or enters the geofence, we're going to send an email, and I can have a distribution list in here, and I've just put my email in. The cooldown is an interesting feature. This is because GPS can be a little bit inaccurate. If I trigger an alert when he enters, 4 minutes here means it's not going to, if the GPS is off a little bit and it looks like he wavers in and out, it's not going to keep triggering. It'll wait 4 minutes until it triggers that again, and you can set that time there. And in this case, I've said, oh, that's not a touchscreen, is it? That's too bad. Hang on. Sorry about that. In this case, I've said I want to get that alert when he enters that geofence, and these are the vehicles down here. I can check off multiple vehicles for this alert. Now, again, it's open source, so you could do whatever you want when that event gets raised. There is basically a geofencing service running in the background that is always comparing the fences you've created against where your fleet is. It raises an event at that point, and you could do anything. In this case, we're simply sending an email, but you know, whatever your organization needs to do at that point is what you do. And let me show you real quick how to create a new geofence. And it's as simple as, let me just back out of here. Hit the new button, and I just start drawing on the map. And I could edit that and make it prettier, but that's how you would create a geofence. You could do this programmatically as well. I was talking to one customer about all of their office locations. They wanted to create a geofence around each location. And you don't have to sit here and do this manually. You can programmatically shove these into the geofence database. So the last thing, I think, yeah, we're running tight on time, so I'm going to show you one more thing, and that is how easy it is to deploy this. So we have this linked from our Bing Maps page. This is where our GitHub is. You can go and grab all of the source code and deploy it manually if you choose to. Many customers do. But we also have a one-click deployment portal which will do this for you. So and this is linked to from the GitHub. So you just come in here, sign in with your Azure account. You will see your subscriptions show up. This is the region you want to deploy to. You put in your Bing Maps subscription key so that it knows how to do the mapping, and that's against your account. And I'll show you a slide in a moment that shows you where to go get a Bing Maps API key if you don't already have one. And you fill in a couple other fields. The send grid one is optional. In the code, we show how to send mail through the SendGrid API, but you might be using a different mail service, or you want to send a text message or do something completely different. So that's completely optional. You hit deploy. That'll send all the code up into your Azure account. It takes about 10 minutes for everything to be up and running. Throw the application on your mobile device, and that's it. You've got a fleet tracker up and running, and then you can start your customization. Real quick, since I'm just about out of time, I'll just very quickly mention, if you don't want to do any of that, we do have partners like Onterra Systems that have taken this and basically white labeled it, and they have solutions ready to go. So if this looks like a compelling solution for your organization, but you don't want to develop it yourself, check out Onterra Systems and some of our other partners who have done that for you. And here's how you would get started. So these are the links if you want to take a picture of this or download these after the show. They'll all be online. This is our GitHub where you can get the code from, download and deploy. Yeah, the instant one-click deployment is there, and one more slide showing you where to get a developer account. All the rest of these are linked from this one, so if you only remember one URL coming out of the show, it's the bingmapsportal.com, and that's where you can create your keys and learn all about all the other APIs that I talked about at the beginning too. So this, the API key that you'll get from that portal works with our map control, our REST APIs, and you can plug it into the fleet tracker as well. Okay, that wraps it up for my slides, and it looks like I have 2 minutes to go, is that right?
No, you're 2 minutes over.
Oh, I'm 2 minutes over. I was going to take questions, and I thought I still had 2 minutes to go, but I'm actually 2 minutes over, so but pop by our booth. We're over in the modern workplace section, and we've got some great giveaways. We've got really good tchotchke. We've got these, Angela, you have one on you? No, you don't have one on you? It's a credit card sized, fits in your wallet. Yeah, there it is. Hold that up, show the folks. It's a 16 gig storage card, so, and it's awesome. It's super tiny, fits in your wallet, 16 gigs. So if that won't get you to our booth, what will? So, all right, thanks everybody.